and it is developed by Modbus organization. Okay. So the security challenges that has been existed with this Modbus are not unusual. So here the authentication and communicating endpoints was not default operation because it allows an inappropriate sources to send the improper messages to the commands to the recipients. So here the messages reach its destination nothing more than the proper Modbus address and function calls. Because of this, the Modbus communication is vulnerable to the industry. So attack has been happening in this. So and also Modbus messages for the applications. So what so for Modbus validation of the Modbus messages cannot be performed by the initializing that particular application. Instead, Modbus depends upon the network stack to perform this particular function. So by doing this, it is potentially it is allowing to abuse the system. Okay. Next protocol is DNP protocol. It is distributed network protocol. So it is being found in multiple deployment scenarios and industries. It is common in utilities and is also found in the discrete and continuous process systems. So like many ICS and SCADA protocols, so it is intended for serial communication between the controllers and a simple AEDs. Next is ICCP, that is Inter-Control Center Communication Protocol. Inter-Control Center Communication Protocols. So this is a common control protocol in utilities across North America. So that is frequently used to communicate between the utilities. So given that it must traverse the boundaries between the different networks, so it holds an extra level of exposure and risk, so that could expose a utility to cyber attacks. As because of this, there are key vulnerabilities, two key vulnerabilities. First one is that the system did not require authentication or communication. Second is encryption across the protocol was not enabled as a default condition. So this exposes the connections on man-in-middle attack, that is MITM, man in the middle, and deploys the attacks. Okay. Next protocol is OPC protocol. OPC is nothing but OLE for process control. What is OLE? OLE is object linking and embedding. Okay. So this is a Microsoft interoperability methodology. So that is being used. So it is basically IT standard protocol. So in industrial control networks, the OPC is limited to operation of the higher levels of the control space. So with a dependence on the window-based platforms. So here RPC is one of the protocol where it is getting attacked. So with which creates two classes of exposures. First one is it requires you to clearly understand the many vulnerabilities associated with RPC. Second, it requires you to identify the level of risk, these vulnerabilities being specific to the internet. Okay, next is international electrotechnical communication, that is IEC protocols. So this IEC 61850, this is the standard, was created to allow the vendor agnostic engineering of power utility systems. So which would in turn allow the interoperability between the vendors and the standardized communication protocols. So the three message types were initially defined. One is MMS, that is manufacturing message specification. Second is GOOSE, GOOSE, that is generic object oriented substation event. And the third one SV, that is sampled values. And there's a fourth one is also there, that is web services. So these are the protocols have been added later. So here MMS is a client server protocol, so that uses TCP/IP and operates at layer 3. So it provides the same functionality as other SCADA protocols such as IEC 60870 and Modbus. The GOOSE, that is it is a second layer. It operates in the layer 2 protocol, so that operates via multicast over Ethernet. So it allows the IED to exchange the data horizontally between the base and between the substations, especially for interlocking measurements and tripping signals. Third one is SV, that is sampled values. This also works under layer 3 protocol that operates via multicast over Ethernet. GOOSE and the SV operates in the multicast over Ethernet. So it carries voltage and current samples typically on the process bus, but it can also flow over the station bus. Okay, IEC 61850 has several known security deficiencies that could be used by skilled attackers to compromise a control system. Authentication is embedded in MMS, but it is based on the clear text systems, clear text passwords, and authentication is not available in GOOSE or SV. Framework is typically not signed. Hence, what happens, which means that there is no way to verify its authenticity or integrity. So GOOSE and SV have limited message integrity, so which makes it relatively easy to impersonate a publisher. Okay. Now, how IT and OT security practices on the systems that it is going to be. The difference between an enterprise IT, that is information technology environment, and an industrial focused operation in technology environment, so deployment, are important for understanding because they have a direct impact on the security practices applied to them. Some of these areas we'll be going to see. That is the first point on the OT point of view, that is the Prudo model for control hierarchy. So what is this Prudo model? That model I have already shown in this. So this model identifies the levels of operations and defines each level. The enterprise and operational domains are separated into different zones and kept in strict isolation via the industrial DMZ, that is demilitarized zone. Okay. So we are having here 5 layers. It is one, that is the enterprise